we are going to do 6.1, 6.2, energy consumption. All right, so a little story before we start. So we start with the sun, the source of all the energy on our Earth. And the sun gives out different kinds of energy, and that is called electromagnetic waves. And so there's short waves like gamma rays, there's long waves like radio waves, but and they're varying things. So we've got, in order, we've got gamma, X-ray, UV light, visible light, infrared, microwave, radio, and this little line is showing us the frequency. So you can see radio waves are very long, gamma rays are very short. Shorter waves, more power, more strength, can get through stuff. Longer waves move slower but can travel longer distances. All of this makes its way to the Earth, and we'll get to more on that in our atmosphere part. But for what we're doing today, visible light makes its way to the Earth, and that visible light is the basis for all the energy on our planet through this guy, the plants, the photosynthesis. So the light comes in, we get our water that's in the soil, and we get carbon dioxide that's in the atmosphere, and the plant makes carbohydrates. It's our form of carbon. So we get that C6H12O, 6, that should be up there. And we get this molecule, this glucose molecule. And from that molecule, notice we've got carbon. And carbon is a basis for all of the processes that are going on, and it helps with our carbon cycle, and it helps us have energy. So glucose becomes energy through cellular respiration, the opposite equation or reaction from photosynthesis. So notice we have to have photosynthesis to make glucose. In the process of making the glucose, oxygen comes out, and the glucose goes into our mitochondria, the powerhouse of the cell, to give us our energy, which is ATP, to do our cellular functions and our stuff. And then the ATP is used up in our bodies. We breathe out carbon dioxide, and we put water out into waste, and then the plant takes that back up and uses it again. So we're breathing plant waste, we're exhaling carbon dioxide, which the plant takes in to keep this going. So this is a feedback loop. It is a positive feedback loop because it's making the system stay and keep cycling around. When we take away plants off this planet, we have less of this cycle happening. When we destroy forests or clear cut or move things out for other purposes like urbanization, we're affecting this process, and therefore we're disrupting the balance of all these cycles. The water cycle that's part of this, the carbon cycle that's part of this, the nutrient cycle that the plant uses to do its growth and its development. So all of this is affected. It's all interconnected. So because of that, we've got these resources that humans can use for energy. So now we're talking about energy in the form of, electricity, transportation, and heat. That's what we use our energy for. 3 basic things. So it's really important you understand what renewable and non-renewable are. So renewable, we can replace at the rate we use it. And non-renewable is one and done. That's kind of the same, but it is not replaceable at the way or rate that we use it. So if you look at these make sense. We've seen oil and coal and natural gas. Those 3 are fossil fuels. And we know fossil fuels take a long, long time, millions of years to form. That is not replacing it at the rate we're using it. The other non-renewable resource in this category is nuclear because it comes from the element uranium. And uranium is an element, so that means we can't make it. So there's only a finite amount, and once it's gone, it's gone. So that's why it falls under the non-renewable category. But it is not, this is really important, a fossil fuel. It does not come from the decay of plants and animals. It comes from an element, but there's only so much of the element, a finite amount. All right, and then over here we've got solar. We can use that over and over. Hydropower, we can, as long as we have water and we haven't, wrecked it and dammed up everything to the point that there's no water flow and we haven't affected the water cycle, we've got water power. Geothermal is the heat of the earth, so the earth is constantly cooling off, so that's a way to capture steam. Wind, because of the topography of our lands, we can generate, well, we are generating airflow, so that's a good thing from plate tectonics. And then biomass, we can take plants, and we have to be careful with this one because if we overtake, then it could become on this side. So we have to be careful how we use some of these resources on the renewable side so they don't get shoved over to renewable or to non-renewable. Okay, so worldwide, we use a lot of energy, and this should not be shocking to you, but coal and natural gas and oil, all the fossil fuels, I shouldn't have picked red, make up the biggest chunk of the pie, right? Let's see, 57, 67, 77, 85% on this pie chart is all fossil fuels. And then we've got nuclear, so that's also a non-renewable. So we could say 89%, this is 2017 numbers, is non-renewable energy sources. And we only have a little bit of these renewables. We've got the water power, little wind power, and solar power together clumped, and then that biomass, just a little teeny bit. So how are we going to go to renewable if it's only like 10 or 11% to 100%? That's a big question in this unit. This is a very cool website. So this is energy use per person in 2019. And it's a very interesting little data chart. So you can tell that the big three are Canada, who's actually number 1, Saudi Arabia, who's actually number 2, and then the US, who's number 3. I'm going to flip out of this presentation. I hope this works for us. And I want to jump over to this chart, and I hope this works for you. So in 1965, and this is ourworldindata.org, so you can look at this website. Let's look at it. Look at the US, 72,922 kilowatt hours per person in 1965. And as we go through the years, I want to go to like the 80s. Now the US is using 86 per person. And then we go into the 90s. The US is using 88. The late 90s were at 92. And now we're back down to 79. So we have, in the US, started conserving our energy at least. Let's watch this again. Just notice which countries come on and off the map and start to increase energy use. Here comes a lot of countries increasing their energy uses. So as countries develop, we are using more energy. All right, so why, if you look at this map, why are the developed countries using more energy than the developing or the lesser developed countries? So we can see some breakdown here. India, using a lot of coal, using a lot of natural gas. They're developing. They are Still using it for basic survival, heat and cooking, a lot of it. What are we using ours for? Heat, cooking, and mostly electricity and transportation. And look what's going on over here. So we're starting to switch. This is good, but we're still using way more energy per person than other countries. Why are we using so much? Why are we so wasteful? Okay, well, a less developed country, they don't have stuff. They don't have a TV, a house with electricity sometimes. They don't have games and phones and computers and a whole bunch of lights. They probably have one or two lights. So they don't have a lot of stuff that needs to be plugged in. Again, they use most of their energy for heat and food and agriculture, just survival, subsistence. When you have a lot of people, you need more energy. So that works for any country. So if you're in a developing country, you have a whole bunch of people because of that population, they need to cook and heat and feed all those people, and that takes a lot of energy. When you have a big old country like this, they all need to plug in and watch TV or whatever they do with their electricity. So we have a lot of people either way needing energy. We may need the energy in a different way, but we're all demanding it. And pretty soon, LDCs will be moving to energy needs to meet more like ours. And then we'll have another pull on the need for energy in the world. Think if 8 billion people all have cell phones and all the electronics that you have, that's going to be another pull or demand on the energy. All right, developed people have less, there's not as many people in the country, but they have more affluence. They're richer and they can buy stuff that requires energy to be plugged in. So there's a problem because the rich people are the developed countries have the money to buy stuff. The developing countries have a lot of people that need the energy to survive and become developed. So they're also using a lot of energy. And our dependence on energy is ever increasing, no matter where people live in the world. If they're a developing country, they're depending on energy. And if we're in the developed countries, we're dependent on energy. Think how many people could not survive without a cell phone right now or without any access to any electronic information. My son tells me all the time he would just die. All right. So consumption of energy over time. You can see what kind has been going on. So biofuels, biofuels is like burning wood. So obviously that's been something we've always done. We can burn wood for heat and cooking and basic survival. And then, of course, Industrial Revolution time comes along. We start adding coal and oil and natural gas. And then we start looking at hydroelectric. And then we started messing around with nuclear in the mid-60s. So, as we industrialize, we increase our demand for energy. So as those developing countries industrialize, they also will increase their demand for energy. All right, so a little side by side. What am I looking at? Make sure you know what you're looking at on a graph. So this is the title, Cost of Energy by each fuel type. So you can see some of these renewables are pretty expensive. Carbon emissions by energy. I mean, this shouldn't be surprising, but sometimes the cheaper energy also is the biggest polluting energy. So we're going to look into that in the next coming days. Okay, so why are we choosing fossil fuels? Well, they are pretty cheap. Our gas is pretty cheap because of fossil fuels. It's pretty easy to mine it, drill it, and get it out of the ground. And the actual quality of the energy is fairly high. So way back in the beginning, energy can't be created or destroyed, but it can be transformed. And so when you first transform it, you have a high quality energy. But you cannot recycle high quality energy into another high quality energy. So when you repurpose the energy, it becomes a lower quality energy. This is basic science stuff you should have learned in chemistry, but I never know what you get in chemistry. So another way to think of this from an environmental perspective is I have a plastic bottle. My favorite thing in the whole world. Just kidding, it's not. And you drink that plastic bottle, and then you're like, well, I'm going to go recycle it. Good for you. So proud of you. Okay, you may or may not know this, but the plastic oil actually comes from petroleum. So this petroleum oil got distilled down and refined and became plastic. Then this plastic bottle, you put water in it, which is made out of oil, and then you drank it, and then you decided to recycle it. This does not become another bottle. It can't, because this law right here, this quality of energy, it cannot become another plastic bottle. So it has to become something else. So it could become a desk, a chair, a park bench. It could become a plastic pencil case. I don't know. It could just be other stuff, but it can't be that again. So that's always a hard concept for APE students to grasp. So recycle does not mean it's going to be that same thing again. The only time that it does become something again is if it's an element. So an aluminum can, yes, can become, because aluminum gets melted down to aluminum and you can redo it. Or glass, because it's made out of silicone. So a glass bottle can become a glass bottle again. But things that are in several different parts and made out of different things, it can never be that again. So it's going to get downgraded to a lower quality and become something else. Another thing to keep in mind when you're drinking out of those plastic bottles. Okay, so this is a 2009 stat. I tried to find a current one and I cannot, because we don't calculate our energy this way anymore. But it's a good thing to look at. This is not as true anymore, because 10 years later, solar panels, photovoltaic cells have actually decreased quite a bit in price. But the point here is, look at the cheaper price of these fossil fuels compared to the renewables and the alternative energies. Okay, so the three kinds: coal, oil, natural gas, solid, liquid, and gas. And we watched a video earlier how these are formed. So remember, it takes a lot of heat, pressure, and time for this to form. That's why, again, they're not renewable. It takes too long for these all to form. Okay, transporting electricity. So how do we get energy? How do we go from a lump of coal to electricity? How do we go from all of these things? So what happens is we get to a power plant, and do I have the whole story here yet? I don't know when we have this whole story. Let me just briefly tell you the story. So let's just go with coal. So we have this lump of coal, and it comes to this power plant. And when it gets to the power plant, it gets crushed and heated. We heat the coal, and when it's heated, we're heating it up over water. And when water heats, what does it do? It boils and it becomes steam, a gas, right? And that steam then goes in to a turbine, which is like a big blade that spins. So the steam is pushing this turbine to start it spinning. And then the turbine is connected to a generator, which is basically a big electromagnet. So these hook together, and the generator spins around, and that moves these electrons that have a negative charge, and moving electrons is the definition of electricity. So let me change colors really quick. So we're going from potential energy to thermal energy to, when it spins the turbine, mechanical energy. Then to the generator, we're getting electric energy. So again, energy can't be created or destroyed, but it can be transformed. And here's the transformation. I guess this also could be kinetic energy because it's moving. Kinetic energy. There you go. Okay, so then that electricity gets to a transformer because you have to step up the voltage to send it a long distance. It gets to your neighborhood and it steps down, and then it goes to your line to your house, and it steps down one more time, so you get the 110 volt that you use when you plug in your stuff. Has to go a pretty long distance just to charge up our phones. Okay, so how does a country or a city choose which kind of energy they want to use? Well, what is there? What can we have access to? Not everybody is near coal. Not everybody is near oil or natural gas or whatever we have, wind, solar, water. So what's around? What can we buy? Supply and demand. What's available? How much does it cost? There's a definite limit of what we're willing to pay for our energy. And what's the government doing? Sometimes the government incentivizes places to use different ones. They'll help cover the cost. Sometimes if they don't want you to use one, they'll charge higher taxes for it. And if it's coming from other countries, they might charge something called a tariff. So make sure you know these 3 words and what they do. Okay, hey, we did it. All right, so that's kind of the intro to energy, and we will get in depth in the next video. So good job, read your chapters.